Hi students, welcome to my YouTube channel, and in today's videos we are going to learn about mole concept and stoichiometry. So the first come in this chapter is Gay-Lussac's law of combining volumes. Actually, Gay-Lussac observed that to produce 2 liters of water, he found that it needs 2 liters of hydrogen and 1 liter of oxygen. You can see this. H2 plus O2 combines to form H2. So when we will balance this, we'll found that here will be 2 and here will be 2H2. Thus the equation is balanced. So we can say that 2 liters of hydrogen when combines with 1 liter of oxygen, it will produce 2 liters of water. So here the ratio of the reactants is 2:1. Hydrogen is to O2, and thus it produced 2 liter of water. And similar relationship he found on other reactions. Finally, he came to the conclusion that whenever the gases combine chemically, they do so in volumes which bear a simple ratio to each other as well as to the product if gaseous under the same conditions of temperature and pressure. This is very much important that they must have under the same conditions of temperature and pressure. For example, I have taken an example of organic compound C2H2, that is actually ethylene. So when we combine 2 volumes of C2H2 with 5 volumes of O2, it is producing 4 volumes of CO2 and 2 volumes of H2. So actually remember that this law is only applicable to gases. We cannot conclude solid or liquid in it. That is why we will not consider the volume of H2 here, as this is in its liquid form. So actually every organic compounds, when they are burned in presence of oxygen, it always produces carbon dioxide and water. So this is a general rule. And now here you can see that the reactants ratio C2H2 is to O2 is 2:5, and thus it produces 4 volume of CO2. So this is a ratio. So as you find the relationship between these reaction, similar relationship is also found over here. This is about Gay-Lussac's law of combining volumes. And now there is a question that 6 liters of hydrogen and 4 liters of Cl2 are mixed and exploded, and if water is added to the gases formed, find the volume of the residual gas. So first see that there are 6 liters of hydrogen and 4 liters of Cl2, and we know when hydrogen and chlorine gas combines, it always produces HCl. And here the reactants will be in 1:1 ratio. That means same volume of hydrogen and chlorine gas reacts to produce 2 volumes of HCl. So here, though there are 6 liters of hydrogens and 4 liters of Cl2, but as there is only 4 liters of Cl2, hydrogen gas will only need 4 liters. Because here only 4 liters of hydrogen will combine with 4 liters of chlorine, as their ratio is same over here, to produce 2 volumes of HCl. So the final product, your HCl will be 2 into 4, that is 8 liters. As in this reaction, the combining ratio of all reactants and products is 1:1:2. That is why if there are 4 liters of hydrogen and 4 liters of chlorine, and it will be 8 liters of HCl, and thus the ratio will but you can see that there are 6 liters of hydrogen but only 4 liters of hydrogen react. So the remaining 2 liters of hydrogen gas is also present. Final volume of the residual gas will be, that will be hydrogen, it will be 2 liters of hydrogen. Now the next question is similar. Like you can see, a mixture of hydrogen and chlorine Cl2 occupied 36 cm³ was exploded. On shaking it with water, 4 cm³ of hydrogen was left behind. Find the composition of the mixture. So you can see that here only 4 cm³ of hydrogen was left behind. That means only 36 minus 4, 32 2 centimeter cube of mixture of hydrogen and Cl2 reacts. So, and we know that in this reaction the ratio of all the reactants and products is 1:1:2. So 32 centimeter cube is the combination of hydrogen and chloride. So here hydrogen gas will be of 16 centimeter cube. Similarly, chlorine gas will be of 16 centimeter cube. And thus your HCl will be what? HCl will be of 2 into 16, 32 centimeter cube of volume. I hope you understand. It has been asked that find the composition of the mixture. So you can say that there will be 32 centimeter cube of HCl and 4 centimeter cube of hydrogen gas, residual hydrogen gas. So I hope you understand. There is another question for you. 450 centimeter cube of hydrogen monoxide and 450 centimeter cube of nitrogen monoxide and 200 centimeter cube of oxygen are mixed together and ignited. Calculate the composition of the resulting mixture. So you can see that here the ratio of all reactants and product is 2:1:2. It means that as there is only 200 centimeter cube of oxygen, this will be 200 centimeter cube and thus it will be 400 centimeter cube. It means that 400 centimeter cube of nitrogen monoxide will react with 200 centimeter cube of oxygen and thus it produce 2 volume of NO2 and according to the ratio you may go that it will be 400 centimeter cube of NO2, nitrogen dioxide gas. And here as there has been taken 450 centimeter cube of nitrogen monoxide, but only 400 centimeter cube of nitrogen monoxide gas has reacted. That is why there will be 50 centimeter cube of nitrogen monoxide gas that has been left behind. So the final composition of the resulting mixture will be 400 centimeter cube of nitrogen dioxide gas and the residual 50 centimeter cube of nitrogen monoxide gas. So this type of question can be asked from this principle. So now next move on to the Boyle's law, Charles law, gas equation. Boyle's law states that the volume of a given mass of dry gas is inversely proportional to its pressure at constant temperature. It means that if we increase the pressure of the gas, its volume will automatically get reduced, and if we decrease the pressure of the gas, its volume will automatically get increased, and this thing happen only in constant temperature. So for example, you can say that there is a gas. If pressure and volume of a gas, of a given mass of gas, dry gas, changes from P1V1 to P2V2, so according to Boyle's law, we can say that P1V1 is equal to P2V2 at constant temperature. Now, Charles' law states that the volume of a given mass of a dry gas is directly proportional to its absolute temperature. Absolute temperature is written in capital T, and it will be at constant pressure. Previously, Boyle's law was considered in constant temperature, where we change pressure and volume of the gas, and in Charles' law we can change the volume and temperature of the gas at constant pressure. And it means that if we raise the temperature of any gas, of a given mass of gas, its volume will automatically increase at this constant pressure. So if there is a gas having volume V1 and temperature T1, and it changes from V1 T1 to V2 T2, so according to Charles' law we can say that V1 T1 is equal to V2 T2. Now this two formula we will use to solve mathematical problems. We will see it later. And next is gas equation. So if we combine the two equations, we can say that V proportional to T by P. So to remove this sign, we can say that V is equal to T by P, And now we can say that V is equal to KT by P. If there is a given mass of gas and its pressure, volume and temperature changes from P1, V1, T1 to P2, V2, T2, then according to this gas equation, or this is a combination of two laws, Boyle's and Charles, you can say that P1, V1 by T1 is equal to P2, V2 by T2. This can be said. So actually this formula is highly important for solving numerical problems, and what I am going to say shortly. On to absolute scale or Kelvin scale. Kelvin scale or absolute scale is just like Celsius scale and Fahrenheit scale. So it is a temperature scale with absolute 0 as a starting point. Absolute 0 means 0 Kelvin, and 0 Kelvin is equal to minus 273 degrees Celsius. So this is a relationship between Kelvin and Celsius. So I have to remember these values. So standard values. Why we need standard values? So from gas equation we see that the volume of any gas changes with temperature and pressure of the gas. So we must have a standard value of temperature and pressure through which we can refer the volume of gas. That is why we have chosen temperature as 0 degrees Celsius or 273 Kelvin, and pressure 1 atm or 760 millimeter or 76 millimeter of mercury as the standard values for temperature and pressure respectively. Now Avogadro's law. Avogadro's law says that under the similar conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. So for example, there you have taken 1 liter of hydrogen gas and 1 liter of oxygen gas, and you have kept them in the same temperature and pressure. So according to Avogadro's law, we can conclude that they both have equal number of molecules. Now atom, the smallest particle of an element, you can say molecule. We know that, for example, there is NaOH base you have taken. So now in NaOH base there are sodium atom, oxygen atom and one hydrogen atom. So we can say that in the element or in the molecule NaOH, sodium atom or atom is the smallest particle. And combining these atoms, there is NaOH molecule. And similarly, we can see that in NaOH base, there are n number of NaOH molecule. That is why, so we can conclude that molecule is the smallest particle of an element or compound. Here NaOH molecule, one NaOH molecule is the smallest particle of NaOH base. Now, atomicity. Atomicity is the number of atoms in a molecule of an element. For example, in hydrogen gas, there is 2 atoms. So the atomicity of hydrogen gas is 2. That is why it is a diatomic molecule. Similarly, oxygen gas, O3, where you will find 3 oxygen atoms. So atomicity of oxygen gas is 3, and thus it is a triatomic molecule. Similarly, you can find octatomic molecules. An example of octatomic molecule is S8, where there combines 8 sulfur atoms. Now, Avogadro's law can predict atomicity of gaseous and molecular formula of gaseous compound. But how it predicts atomicity of gases? Let's have an example of nitrogen gas, O2 gas, that produce 2NO. So here, according to Gay-Lussac's law of combining volumes, we can say that one volume of nitrogen gas react with one volume of oxygen gas and thus produce 2 volume of nitric oxide. And from Avogadro's law, we say that one molecule of nitrogen gas combined with one molecule of oxygen and thus produce 2 molecule of nitric oxide. So again we can say that half molecule of nitrogen gas combined with half molecule of oxygen gas to produce one molecule of nitric oxide? So, as molecule can be divided in atoms, but atoms is indivisible. So, you can say that half molecule is equal to one atom of nitrogen gas and half molecule of O2 means one atom of oxygen gas. So, it means that one molecule of nitrogen gas have two atoms of nitrogen, because as there is half molecule of nitrogen gas means one atom of nitrogen gas. So we can say that one molecule of nitrogen gas will have two atoms of nitrogen. So thus it says, it predicts the atomicity of nitrogen gas, that is 2, as it has only two atoms, two nitrogen atoms. Similarly, we can say that one atom, half molecule of O2 is equal to one atom. So, one molecule of O2 will be two atoms. So, the atomicity of oxygen becomes 2, as there is two oxygen atoms. Now, Avogadro's law can also predict the molecular formula of gaseous compound. So let's have an example. So experimentally it has been found that two volumes of hydrogen combines with one volume of oxygen and thus produce two volumes of water. So from Avogadro's law we can say that two molecules of hydrogen combines with one molecule of oxygen and thus produce two molecules of water. Similarly, one molecule of hydrogen combines with 1 by half molecule of oxygen and thus produce one molecule of water. And half molecule means one atom, as previously I have told you, and one molecule is equal to what? One molecule of hydrogen gas is equal to two atoms of hydrogen. So from this we can say that water contains, one molecule of water contains two atoms of hydrogen and one atoms of oxygen. So the chemical formula of water will be H2O. Now move on to relative atomic mass. So before that we have to learn what is atomic mass. So please listen to me carefully because this part is quite confusing. So actually the atomic mass is the mass of single atom of a chemical element. Now we know that atom consists of proton, neutrons, electrons. But electrons it's so light. That is why you can neglect its mass. But for proton and neutron, we know that mass of proton and mass of neutron is similar, and that is 1.6 into 10 to the power minus 27 kg. And now we cannot use these values everywhere to determine the atomic mass of any atom. What we can do? That simply we can convert it into 1 U. So 1 U is equal to 1.6 into 10 to the power minus 27 kg, and we will use this 1 U everywhere to determine the atomic mass of any atom. Okay. For example, carbon, its atomic number is 12. Now it has 6 protons and 6 neutrons. So we can say that its atomic mass will be 12 U. So thus we can determine atomic mass of any atom. But what happens that most natural elements are a mixture of two or more isotopes. For example, even carbon, C12 is mixture of C12, C13 and C14 isotopes. So in this case, what we can do? We can simply take the average weight of all the naturally occurring isotopes. And for this reason, we need, here comes atomic weight. So atomic weight is the weighted average of the naturally occurring isotopes. For example, you can say chlorine has two isotopes with 37 and chlorine 35. This is their mass number. Their difference is only in their neutrons number. Their isotopes, because isotopes are those where atoms of the same element having same atomic number but different mass number are known as isotopes. So here chlorine 37 and chlorine 35 both have same atomic number, but the difference is in their mass number. And here the atomic number of chlorine is 17. Okay, so now to determine its atomic weight, what we can do, we have to take their average weight. For example, this chlorine 37 and chlorine 35, they present in nature in 1:3 ratio. So to take their average, we can do 37 into 1 plus 35 into 3 by 4. Because 4 is the total amount, 1 plus 3 is equal to 4. Okay, now computing this value, we'll found that it will be 35.5. So this is the actual atomic weight of chlorine. But always remember the difference between atomic mass and atomic weight is that atomic mass is the mass of single atom of any chemical element, while atomic weight is the weighted average of the all naturally occurring isotopes of that element. Okay. Actually, this type of mass, atomic mass, is also called fraction atomic masses. So you can say that chlorine have a fractional atomic mass. Now here come the way relative atomic mass. So relative, because here we are using 1/12 of the mass of an atom of say C12. But why there needs a relative? Because for example, when you go to market to buy some grocery, for example 1 kg of rice, so this is given to you only after measuring with another 1 kg of weight. So here when 1 kg of weight is using as a reference to measure of 1 kg of rice. Similarly, in the world of atom, the weight of atoms is measured with a reference. And here 1/12 of the mass of an atom of C12 play the role. And exactly here you can see that as 12U is the atomic mass of C12, so 1U is actually, or you can say 1 atomic mass unit is actually the 1/12 of the mass of one atom of C12. You can say 12 into 1/12, so is equal to 1. So that is why you can say that the 1 AMU, 1 atomic mass unit, is equal to 1/12 of the mass of one atom of C12. So why we are using C12 as reference? Despite there are several atoms we can use. Actually, there are some properties that make C12 more preferable, because this is neither least nor more reactive. First one, this is highly abundant in nature and it has less abundant isotopes. For example, I have told you that carbon has 3 isotopes, 12, 13, 14. But these 13 and 14 is very rare in nature. Only C12 is present in highly abundant quantity. That is why we are using C12, the C12 isotope of carbon. Now, there is another thing. When relative atomic mass of an element expressed in grams is called gram atomic mass or gram atom. For example, C12. Just now we determined that carbon 12 has atomic mass of 12U. Now if we convert it in gram, we can say that atomic mass of carbon is 12 gram. Now, in this 12 gram, we cannot say that one atom of carbon has the weight or mass 12 gram. But actually it is a combination of atoms that makes the weight 12 gram. And experimentally it has been found that 12 gram of C12 has 6.023 into 10 to the power 23 number of molecules. And as we are using this C12 isotope everywhere to determine the relative atomic mass or atomic weight to determine molecular weight, so that is why I can say that this number of molecules we can take it as a reference, and this will be 1 mole. You can say this is the 1 mole. We can say so a mole is the amount of pure substance containing the same number of chemical units as there are atoms in exactly 12 gram of carbon 12. So this is the definition of your 1 mole. Okay. So simply a mole is a collection of 6.023 into 10 to the power 23 particles. Now the quantity of element which weighs equal to its gram atomic mass is called 1 gram atom of the element. For example, 12 gram of carbon is equal to 1 gram atom of carbon. Actually, there is a very slight difference between gram atomic mass and gram atom. So now move on to relative molecular mass or molecular weight, the number of which represents how many times one molecule of a substance is heavier than 1/12th of the mass of an atom of C12. So relative molecular mass can also be determined like relative atomic mass, but here molecule plays a role, and we know that molecule consists of atoms. Now you are asked to determine the molecular mass or molecular weight of H2. Now we know that hydrogen atom has atomic mass or atomic weight 1. As there is 2 atoms of hydrogen, so we have to take 2 into 1. And we know that oxygen has atomic mass 16. So we have to add 16 with it, and thus we'll get 18. So this is the molecular mass, and from here we can say that the molecular mass of H2 is 18 AMU, atomic mass unit. So we can also say that one molecule of H2 is 18 times as heavy as 1/12th the mass of carbon atom of C12, because we just keep this as a reference. So now just I have told you that what is atomic mass of an element. So you were asked that what it means that atomic mass of oxygen is 16. What it means? So it means that one atom of oxygen is 16 times heavier than 1/12th of mass of a C12 atom, and I have told you that 1/12th of mass of a C12 atom is actually 1 AMU, 1 atomic mass unit. And I have also told you C12, atomic mass of C12 is 12. So now 12 gram of C12 has 6.023 into 10 to the power 23 number of atoms. So carbon 12, we can also say that oxygen that has atomic weight of 16 gram, and in this 16 gram of oxygen there is 6.023 into 10 to the power 23 number of atoms. So it means that 6.023 into 10 to the power 23 number of atoms present in 16 gram of oxygen, that is its gram atomic weight. And previously I have also told you that 1 mole is a collection of 6.023 into 10 to the power 23 particles. So it means that it is actually 1 mole. So thus we can conclude that 1 mole of atoms contains 6.023 into 10 to the power 23 atoms having mass equal to its gram atomic mass. Now if we take the example of H2, I have told you that its gram molecular mass of H2 is 18. It means that in 18 gram of H2 there is 6.023 into 10 to the power 23 number of molecules. This number of molecules is actually 1 mole. So here for H2, as this is a molecule, we can say that 1 mole contains 6.023 into 10 to the power 23 molecules, that is equivalent to gram molecular mass of H2, that is 18 gram. So this is the mole of molecule. So simply you can say that 1 mole contains 6.023 into 10 to the power 23 molecules and is equivalent to the gram molecular mass of any given substance. So this is the definition of mole of molecules. So we can conclude that 1 gram molecular mass of any substance, it is 1 mole and it has 6.023 into 10 to the power 23 number of molecules that is 22.4 liter at standard temperature and pressure. Now, this thing is important. What is 22.4 liter? Actually, this is the molar volume. The molar volume of a gas can be defined as the volume occupied by 1 mole of a gas at STP. So, if we see that if there is, for example, 6.023 10 to the power 23 number of gaseous molecule, it occupies 22.4 liter of volume at standard temperature and pressure. So, the number which represents how many times of one molecule of a substance is heavier than 1/12th the mass of an atom of C12 is called the relative molecular mass of that atom, of that molecule. So now just we express the value of relative atomic mass of an element in grams and we called it as gram atomic mass or gram atom. Similarly, the relative molecular mass of any molecule can be expressed in grams, and there it will be gram molecular weight or gram molecule. So just I have given an example of H2O. I have told that H2O has molecular mass 18 AMU. When we will express this term in gram, we will say that molecular mass of H2O is 18 AMU. Therefore, its gram molecular mass is 18. So, I hope you understand. Thus, I have explained all the things that is relevant to this topic. Still, if you have any doubts, you may ask in the comment section. I will give reply to you. Now, next move on to solve some questions. So, now listen to me carefully. I am asking that calculate the mass of one atom of oxygen. So, I just have told you that gram atomic mass of oxygen is 16 and these 16 gram have 6.023 into 10 to the power 23 number of atoms, and thus we can say that these 6.023 into 23 atoms will have the weight 16 gram, and thus one atom of oxygen will have the weight 16 by 6.023 into 23. And thus this will be 2.657 into 10 to the power minus 23 gram. This is the mass of one atom of oxygen. Now if you are asked to calculate the mass of one molecule of oxygen, so just I have told you that oxygen molecule O2, as it has two atoms of oxygen, that's its molecular mass will be 2 into 16, that is 32 gram. So 32 gram of O2 has 6.023 into 10 to the power 23 number of molecules. So one molecule weight 32 by 6.023 into 10 to the power 23, and thus it will be 5.314 into 10 to the power minus 23 gram. So this is the mass of one molecule of oxygen. One molecule of oxygen. Okay. Now for example, you are asked to determine the molecular mass of CaOH2, calcium hydroxide. And it is given that atomic mass of calcium is 40, atomic mass of oxygen is 16, hydrogen is 1. So 40 plus, as there is 2 OH and 1 OH is equal to 1 atom of oxygen, that is 16, plus 1 atom of hydrogen is 1, is equal to 17. And thus, as there is 2 OH, so we have to multiply 2 with 17, and thus it will be 40 plus 34 is equal to 74. So this is the molecular mass or gram molecular mass of CaOH2, and it is 74 gram. Now I have told you that gram molecular weight of all gases at STP contains 6.023 into 10 to the power 23, that is the Avogadro's number, molecules which occupies 22.4 dm cube or 22.4 liters of molar volume. So I have already told that what is molar volume, and so it means that if you have 1 gram molecular mass of a substance, it will be 1 mole of that substance. It will be 6.023 into 10 to the power 23 number of molecules, as we are considering gram molecular mass over here, and it has 22.4 dm cube or 22.4 liters, or you can say 22,400 milliliter of molar volume. And molar volume is that this substance occupy this volume in standard temperature and pressure. So I hope you understand. Now one thing I must say that, for example, CaCl2. So now if we dissociate CaCl2, there will be 1 Ca2 plus ion and 2 Cl minus ions. And if we watch it carefully, we will find that there is 2 atoms of Cl2, 2 atoms of chlorine and 1 atom of calcium. When we will consider that there is 1 gram molecular mass of CaCl2, it means it will have 6.023 into 10 to the power 23 number of molecules. And similarly, in this CaCl2 molecule, the number of calcium atom will be of 1 gram atomic weight, gram atomic mass, and thus here it also will be 6.23 into the power 23 number of atoms. Similarly, as there is 2 atoms of chlorine, so we can say that in 1 gram atomic mass of CaCl2, that is 40 plus 2, 35.5, it is T plus 71, 111 gram. So in 111 gram of CaCl2, there will be 1 mole or 1 gram atomic mass of calcium that contains 6.023 into 10 to the power 23 number of atoms, and it will also have 2 mole of chlorine atom, that is 2 into 6.023 into 10 to the power 23 number of chlorine atoms, or 2 moles of chlorine atom. Similarly, when we dissociate calcium chloride in Ca plus 2 and 2 Cl minus ion, there will be 1 mole of, that is 6.023 into 10 to the power 23 number of Ca plus 2 ions, and there will be 2 mole of this 2 mole of chlorine minus Cl minus ion. So from this we can conclude that in 111 gram of calcium chloride, there will be 6.023 into 10 to the power 23 number of molecules and 6.023 into 10 to the power 23 atoms, or 1 mole of atoms of calcium, 2 moles of atoms of chlorine, 1 mole of calcium ions, and 2 moles of chloride ion. So this is a general rule. You have to remember this example always. Now there is another thing I have written over here, that number of moles is equal to weight in grams of the substance by molecular weight of the substance. For example, you are given 28 gram of nitrogen. Now you have to find the number of moles of atoms of nitrogen atoms present in this 28 gram of nitrogen. We know that nitrogen has atomic mass of 14 gram. So this is the weight given to you, given weight 20 by 40 is equal to 20 mole. It means that 20 moles of nitrogen atom are present in 28 gram of nitrogen. That's how you can use this formula, that number of moles is equal to weight in grams of the substance by molecular weight of the substance. So similarly you can determine the number of moles of molecules, the number of moles of ions in the same process. So now next move on to vapor density. Vapor density is the ratio of mass of certain volume of gas or vapor to mass of same volume of hydrogen gas under same temperature and pressure. We can write that relative vapor density is equal to mass of certain volume of gas or vapor by mass of some volume of hydrogen under same condition, under same temperature and pressure. And according to Avogadro's law, volumes at the same temperature and pressure may be substituted by molecules. Hence, we can write the formula as mass of one molecule of gas or vapor by mass of one molecule of hydrogen. Now we all know that hydrogen has 2 atoms. Okay. So if we multiply both side by 2, we'll get 2 RVD, relative vapor density, is equal to mass of one molecule of gas by mass of one atom of hydrogen. Because if we take 2 from this side, it will be 2 into 1 atom of hydrogen, and as we are multiplying 2 with this side, we'll cut this 2 and thus the final thing will be mass of one molecule of gas by mass of one atom of hydrogen. So actually this thing, can you relate it? This is actually telling you about the relative molecular mass. So that's how we can conclude that relative molecular mass is equal to 2 RVD, or relative molecular mass of any molecule is twice of relative vapor density of that molecules at same temperature and pressure. Now I have a question for you. A gas cylinder filled with hydrogen holds 50 gram of the gas. The same cylinder holds 200 gram of a gas X and 500 gram of gas Y. Considering the same conditions of temperature and pressure in the cylinder, calculate the relative molecular masses of gas X and Y. Now we can see that we are considering the same conditions of temperature and pressure. So it may somehow the question relating to vapor density. So as we know that relative vapor density is equal to mass of one molecule of gaseous or vapor by mass of 2 atoms of hydrogen. So here you can see that this gas, we know that relative vapor density is equal to mass of certain volume of gas or vapor by mass of same volume of hydrogen. So here gas X is 200 gram while hydrogen has 50 gram. So it will be 40 relative vapor density. Now relative vapor density has no unit because it's a ratio. And again gas Y has 500 gram and here hydrogen has 50 gram. So it will be 10 for gas X. Now you have to calculate the relative molecular masses of gases X and Y. And just now I have told you that relative molecular mass is equal to 2 into relative vapor density. So for gas X it will be 2 into relative vapor density 40, that is 80. And for gas Y it will be 2 into 10, that is 10. Actually relative molecular mass has no unit because it is a ratio just like relative vapor density. That is why there is no unit of relative molecular mass. So the final answer will be that relative molecular mass of gas X is 80, relative molecular mass of gas Y is 20. Now I have taken another question for you. The mass of 5.6 liters of certain gas at STP is 12 gram. What is the relative molecular mass or molar mass of the gas? So I have told you that 1 mole of gas or 1 gram molecular mass of gas or relative molecular mass of gas has 22.4 liter volume at STP. It is given that 5.6 liter of certain gas at STP has 12 gram. But to determine relative mass, we have to calculate them through 22.4 liter. In 22.4 liter, the mass of the gas will be 12 into 22.4 by 5.6. It is 48 gram. So this is the relative molecular mass or molar mass of the gas. Okay. Next question is, calculate the mass of 0.1 mole of CaCO3. Find the number of Ca and carbonate ions in 50 mg of CaCO3. Now, CaCO3 has 1 calcium atoms of 40 gram atomic mass, 1 carbon atom of 12 gram atomic mass, 3 oxygen atom of 16 gram of atomic mass each. So the final thing will be 100. So this is the gram molecular mass of CaCO3. This 100 gram of CaCO3 is equal to 1 mole. Now the question is, find the mass of 0.1 mole CaCO3. So 0.1 mole of CaCO3 will be 100 into 0.1. This is 10 mole, 10 gram. So in 0.1 mole of CaCO3, there is 10 gram of CaCO3. Now find the number of calcium and carbonate ions in 50 mg of CaCO3. Now we know that when CaCO3 dissociates, it produces 1 Ca calcium plus ion and 1 CO3 2 minus ion. And I have told you that there will be 1 mole of ions or 6.023 into 10 to the power 23 number of ions present in 1 mole of CaCO3. And now we can say that in 100 gram of CaCO3 there is 6.023 into 10 to the power 23 number of ions. It means in 1 lakh mg of CaCO3 there is 6.023 into 10 to the power 23 number of ions. And finally you have to determine the number of ions in 50 mg. So it will be 6.023 into the power 23 by 1 lakh. And the final answer will be now you have to determine the final answer. I don't. So this will be, and the resultant will be the final answer, the number of ions present in 50 mg of CaCO3. Now the next question is, the molecular mass of A is 50 gram. Calculate the mass of the substance A, which is in gaseous form occupies 20 dm cube at 27 degrees Celsius and 600 millimeter pressure. Now one thing you must have to remember that I have told you earlier, that is P1 V1 by T1 is equal to P2 V2 by T2. And I have also told you what is standard pressure, standard temperature. As volume changes with pressure and temperature, so that is why we must have some standard value of pressure and temperature through which we can determine the volume easily. So I have told you that 760 millimeter of Hg is standard pressure, while 273 K or absolute temperature is the standard temperature. So now here it is given that the mass that substance A in gaseous form occupies 20 dm cube at 27 degrees Celsius and 600 millimeter pressure. Now we can convert 27 degrees Celsius in absolute temperature, and this will be 2073 plus 27, that is 300 K. Okay, and this is 600 millimeter pressure, so we can say that 600 into V1 is what? 20 dm cube. 20 by 300 K is equal to P2. 760 into V2. 273. Now if you calculate this, we will get 2, it will be 40, and then this will be 14.36 dm cube. So we can say that at 760 millimeter of mercury pressure and 273 Kelvin of absolute temperature, the volume of the substance A is 14.36 dm cube. Now you have to say, you have to determine its mass of the substance in this condition. So we know that from molecular mass of A, we know that at STP 50 gram, as the molecular mass of A is 50 gram, so 22.4 dm cube of volume will have 50 gram of A. The weight of the 14.36 dm cube will be 50 into 14.36 by 22.4, and the final answer is 32 gram. So the substance A in gaseous form occupies 32 gram. So students, thus I have completed the chapter. So if you have any doubts, go straight to the comment section, ask me, and if you want any short notes from this chapter, then mail me. I have given my mail address in the description box. Check it there, and I will provide the PDFs of those short notes to you. Finally, thank you for watching.